Hi, and welcome to CISPA TLDR, the cybersecurity podcast from the CISPA Helmholtz Center for Information Security. Every month, we bring in our researchers to share insights into the latest challenges in cybersecurity and AI that CISPA is tackling. Don't worry, we keep things simple and steer clear of technical jargon, so you can follow along even without a background in computer science. I'm Tobias Ebelshäuser from CISPA's communications team, and trust me, I don't have a computer science degree either. My guest today is Aleksei Stafeev, a PhD student at CISPA. He's working on web security, automated security testing to be exact. Welcome, Alex. It's great to have you here.
Thank you for having me.
So you're working, as I've said before, you're working on web security.
Correct.
How did you get there? Is there something that particularly fascinated you about that area? How does one start with a topic like that?
Yeah, well, I've been infatuated with cybersecurity since high school, actually. I've been playing these cybersecurity competitions called Capture the Flag with my friends. And they're very rewarding. Like when you finally understand how the computers work, how the software works. Yeah, and you just learn a lot in general how computers work and how software may be developed.
But how do you get into that? How do you start with like Capture the Flag competitions? Do you find them on the internet, or how did you and your friends come to actually do that? And how does it work? Because I've read about it a lot and I've heard about it, but for me it's just, I don't know. When I think of Capture the Flag, it's like the shooter game, but so.
I mean, it kind of is, I guess. So for me, it was, I think, I don't actually quite remember what I was doing at that date, but I vividly remember that I came to my friend who was sitting in the corner doing something on his laptop. I was like, hey, what you doing? And he said, well, I'm like doing this Capture the Flag. And he briefly explained to me how it works. I was like, oh, it sounds really cool. It might be right up my alley because I like software engineering. At that point, like I already was coding a little bit, and it sounded quite fun, like doing some kind of hacking.
So how old were you at that point?
16 probably, so yeah. Something like that. He just showed me the website. I went there. It was like specifically targeted at high school. The challenges were pretty simple, but challenging enough. Yeah. And I basically like solved all the challenges then, and that was like that was the moment for me. Like, okay, this is super cool. Like, I want to do it
you went
more.
Down the rabbit hole.
I want to do it more. I think it also helped that this particular challenge was like going for a few days. So I had time to actually like understand whatever is happening. What do they want from me? Yeah. But yeah, you basically just look. There is some description of the problem that, hey, like we have this, I don't know, network traffic captured, for example, and you need to find the flag there, and you like open specific software that allows you to like read the logs and understand what happened in this time frame, and then you find, oh, okay, here was like network request, and the result of this network request was like the flag. Like it is usually just a string that says, hey, like you found me. Basically. But as you go, like playing these competitions, like some of them are team-based, like you don't play alone, like you actually go with your friends, because there is not so much time and there are so many challenges. You actually need to like strategically approach this problem. Like you need to decide, okay, I'm strong in this particular set of challenges. For example, if you like web challenges, like then you might tackle those. There are other challenges like for the typical software, like binary programs and so on. Forensics, cryptography, and so on.
Okay.
And as you play those, you open to you getting exposed to these competitions that get harder and harder. So even if before it was pretty simple to get the answer, but now you suddenly have this very complicated software that you actually need to spend a few hours on and try to understand what exactly is happening there. Yeah. And find the vulnerability or find something hidden inside. So, for example, for the high school students, I think the very easy like entry level challenges are like stenography challenges. So where you have a picture, but there is something hidden inside, and all very simple cryptography like Caesar's cipher. Yeah. So you might find the same challenges, I don't know, in just like logic puzzle books and so on.
Okay. It's just to get you hooked.
Yes, it's to get you hooked. But the thing is, like all the other like more complicated stuff and all these vulnerabilities in security in general, it's all basically the same puzzles. Like to everyone who works in security, if you ask them, it's just puzzle solving, most likely.
Okay.
You need to figure out how the program works, what are the inputs, what are the outputs, and like how does it get from point A to point B. And you might notice that, apparently there is actually a way for you to use the software in the non-intended way, which actually gives you something really cool. For example, you are not allowed to access this specific part of the application, but suddenly you actually can. Like if in a very particular way you approach the program, you can actually do that. Okay. Or you can buy, 100 burgers for $1, for example.
But that sounds like it adequately prepared you for your career in cybersecurity research now.
Yes. I mean, that was definitely the moment for me where I was like, I want to do it, and I want to do it more. Yeah.
Now you're here at CISPA, and
I mean, even before, like after high school, I was also playing in the university, and after university, I also went to like company to actually work as a security researcher.
Okay.
Looking for vulnerabilities in the applications, and then I decided, I also want to do PhD. I went.
So you have been in industry before and gotten back to research then?
Yes.
And why is that?
I wanted to have more research because in industry it was more like, here is an app, go hack it. Here it is more here's the problem, try to solve it. Like we have this problem in general. Like it's not just hacking a single application. It's about either identifying this particular vulnerability in like many web applications or like in many applications in general, and also if you can, also if there is a fix that you can apply to all of these applications so that there is no such vulnerability anymore. So it's
a more holistic approach to actually solve problems that a lot of developers have while developing.
Yeah, definitely.
Okay. But now you focus specifically on web applications in your research. So maybe let's start at the beginning. What's a web application, and what's the difference to what we would typically call a website?
To me, web application is actually a software that powers the web application, because if you if you visit the website, you just see some web pages, some buttons, you click on them. Here's the typical understanding of what a website is, right? Just some visual textual information on your computer. But the web application, to me, it's something that runs in the background, this code that was written to display this.
I visit an airline website because I want to book a flight. I have a lot of buttons, a lot of layout, but there's a software running behind it that is actually giving me the correct data.
Which integrates with other systems. If it's a booking system, then probably something like also like payment systems and all that stuff.
Okay, and you have worked on web crawlers that automatically scan these web applications for vulnerabilities or other security problems. Can you tell me how such a scanner would typically work? How would it go at finding bugs on? Let's take the example, if that works for you, the flight booking software or the flight booking web page.
Well, in general, security scanners on the web are pretty simple, but there are like two main components. If you look at the security scanners, you will most likely find these two components, or at least one of them. There is the crawler component, which does the reconnaissance on the website. So it needs to go out there, click on buttons, follow the links, and to collect the pages and links from the website. And then there is this attack module, which actually does the security testing. So it has some kind of algorithm to test this particular vulnerability.
Okay.
But it needs as an input a specific page or a specific link to test on.
Okay.
Yeah, that's very simple. Like do the reconnaissance and then do the testing.
Do the testing sounds like there's a little bit more to it.
I mean, definitely. It's just that it could be very, very different techniques that could be employed for all the different vulnerabilities. It could be some brute forcing, just trying all the different data. Let's just say, for example, you want to test a payment form. you would test all the different inputs you can send on this form. You can try to mix and match the card IDs, I don't know, the names for the card, and then see what happens. If you can maybe send some special symbols that in the web application, like on the behind the curtain, like all this like machinery running in the background, if you can somehow tamper with it, like send some data that was not expected by the developer, and see if it breaks anything. Other techniques could involve actual exploitation. Like, yes, if you know that there is a specific vulnerability, so this is basically refers to the thing I said before, that some scanners might not actually have a crawler component. These are most likely scanners that test already known vulnerabilities. So for example, there was an advisory that this, I don't know, web application that powers a lot of websites has a vulnerability. And if the exploit for this vulnerability is known, that the people know that, okay, it is this specific vulnerability is located on this specific page in this web application, then we can simply go to this page, test if I don't know, if the version matches, for example. That's a very simple test to see if it's vulnerable or not. Also, the same thing could be done even without the pages if the website actually tells you the version just straight away. Like, if you visit the website, it tells you, oh, okay, I'm running this program version, I don't know, 1.0. And you know that this is vulnerable, then you found yourself vulnerable.
So summarizing, the crawler basically draws a map of the website. So it just looks at every possible instance on subpages and everything and says, okay, this is what a website looks like. You could go to each of one of these directions being like a link or a subpage or something. And then the actual testing begins, right? And then that could involve a lot of different things. Said. Okay.
It is just very specific to the vulnerability you're looking for. All of them are pretty different, and they require different approaches.
So what does it look like in the real world? I mean, you said that you worked for a company where you've tested these apps. Would you go and look for specific vulnerabilities, or is there like a whole suite where you just push test and then it's tested for everything that you could currently think of? I mean, what does it look like?
Yeah, it actually depends on your position from which you are testing. So, for example, let's say I would say there are two different approaches to this. One of these is internal testing. So if you are working for the company that actually makes this application, or you're working for the company and you have this application running, but you also have an option to like just test it, like just have a staging environment in which you can freely test without making any users at risk. Like it doesn't use any users' data. In this case, you can run the suite and like just run whatever test you're available. You can like hammer it down with requests, brute force everything without like any care for the world. Like you can break it however you want. Just run automatic tools, and this is perfect chance for you to test it extensively. However, if you are outside researcher or outside security tester researcher,
yes, you are now.
Yes, in this case, your options are quite limited. First of all, you need to make sure that you can actually test this application. So this is mostly applies to bug bounty hunters, which they do not even have any connection to these companies. They just know that, the company wants you to test. But if it does not, then, you should not test it. So first of all, you should have a license, permission to test. Then you need to make sure that whatever you are doing on this website actually does not pose any risk to other users. And in case of automated software, this is actually super hard. Because whatever you do, you need to precisely understand what consequences will this involve. So let's say if you send this symbol that is not typically supposed to go in this field, what are the risks? Like, is it possible that if you send this symbol, for example, all the database going to be wiped? It's quite possible. You never know what exactly running in the background. It could be that whatever you send actually can wipe the database or leak other users' data. So it's very important for you to approach it ethically and responsibly. Therefore, your options are quite limited of whatever you can do. So if you want to run tools, tools probably should be very simple, not sending any data, probably just following the links. That's the most you can do. Whatever you do, it's either you're being allowed to do that or you do it locally. These are two options.
Yeah, that makes sense. I think it's good advice. Okay. So getting back to how the crawler works when it, let's just say when it draws the map of a web page. So typically it would just go about that randomly, right? So you would just, maybe you can describe it a little bit.
It could go either randomly and just given up, like, let's say it starts on the front page. It sees all these links and buttons on the page. It just will click on a few. Let's see where it leads to. It can do it in random order. So just shuffle it around, see, and click on whichever button.
So maybe let's specify it, because when I think about that, it kind of sounds like it's actually like a software that does that like in the same way we humans would do it, like clicking, but it probably does it on a page level, right? So it sees a tree of links and it just follows them in a way.
Yes. So it has typically the crawler does not have a visual clues. It only sees elements on the page, like on the program level. That here are the 10 buttons. They have these labels, but it may actually not use any labels. So it cannot distinguish between create and delete button, which is actually a pretty crucial information to me, if you ask me. It has this like choice. Okay, I'm on this page. What should I do next? I need to do something. So your options are click on the buttons, maybe fill the form. And well, you don't have many options on how to do that, right? You can just randomly pick one button and click on it. You can just go in order, on like whatever order you extracted them, like just left to right, I don't know, top to bottom. Or you can go in the reverse order. Or after you click, do you go back and click the other button, or do you follow and just continue clicking and clicking and clicking until, I don't know, you cannot click anymore.
But semantically, there's like no sense to what the crawler is doing. It's just doing random clicking. Even if it's not really random, there's no sense to it.
Exactly.
But on the latest crawler you have been working on, you have tried to do away with this problem a little bit. So
yes, as I said, like traditionally, all these crawlers and scanners, they do not really use this semantic information that we have on the website. So as a humans, when we interact with the websites, we see that, okay, here is the button to go on the, I don't know, accounts page. Here's the button to go to see all the tickets for this country, stuff like that. Typically, crawlers just don't use this information like at all. They just click and click and click. They then just like click wherever. And the issue with that is that if you want to reach this like deep functionalities of the website, so let's say if you want to like going back to the example of flight booking, if you want to book a flight, you need to do a sequence of actions in a specific order. You need to select the country, the airport you're flying from, select the airport you're flying to.
In date, you need
the date,
passenger number.
Yes. Click on search. You have then a list of tickets. You pick one of them. Then you need to enter your information, like your name, your surname, your personal ID, and so on. Then you click next. You need to select a seat. Then you need to fill out your payment data. So like a lot of steps, and you need to follow very specific sequence of actions. You do not click back at any of these steps. You do not click on the home button, for example,
or on the about, or on the FAQ.
Like you do not click on these buttons. I mean, you can, but the problem will be like if you are just one step before, the whole workflow will just break down. You need to like re-execute it once again.
So doing that randomly, the probability of reaching the checkout is...
The chances are very, very low that it will follow through and click on this payment button and like finish the booking. And if you do security testing, we're super interested in all these workflows. So this final like booking request this is what we're interested in, because this is what we can interact with and then try to switch some fields. I don't know, fill out some data that maybe not expected on the back end, like in the background on this website. This is what we're interested in. So for us, the fact that these crawlers cannot really reach this functionality is a pretty big deal.
Yeah.
And but recently we've seen the rise in popularity of these large language models, and we know that they have been trained on the web and on the data coming from the web. So given like this understanding, we expect them to somehow being trained also on the data, on the documentation for these web applications, for the websites, because there are a lot of those on the web. So in theory, this means that we may actually tap into this knowledge and use it to interact with the websites in a more semantic way. Yeah. And with our paper, we basically bridge this gap that we couldn't do before. I mean, there have been other works that tried to do the same thing, but they were quite limited and didn't really scale well. However, with the large language models, we can actually try and fix this and approach this problem from this angle. So we tap into this knowledge to enhance the traditional scanners architecture by adding this semantic interaction with the website.
So to add some more detail on your project, it's actually called the YuraScanner.
Yes.
Which you already told me it's a kind of a wordplay.
Yes. So if you've seen how the prompts is usually like created, there is this very popular technique which gives the sense, like this context to the model, that what it's trying to do. So very common approach is to start your prompt with you are an assistant, you are manager, and so on.
You are a writer trying to finish their manuscript.
Yes, exactly. You're a podcaster, and now you're a podcaster, and now you need to create a script.
We would never do that here.
Yeah. So in our case, we say you're a scanner. So you're a scanner.
Okay. Yeah, that makes sense. And your paper will be presented at the NDSS conference in San Diego this month. Can you tell us what large language model you used for to actually integrate it to your scanner?
In our experiments, we used OpenAI GPT model 4, number 4. At the time of our experiments, it was the one that performed the best, basically. At the moment of recording this podcast, this might not be true anymore. But at the moment of our experiments, we tried different models, like from Meta, Llama, and others, and they did not perform as well in our experiments. So we just proceeded with the OpenAI model.
Okay. So
in this case, like the approach is pretty general. You can use whichever model you want, as long as the performance is quite good.
Yeah. Okay. So let me try to summarize again. So the typical random web scanners that were used in the past, they basically fail at the semantics of the website because they don't really understand what they're doing. Yes. They are not like seeing the web page in a human way, and they know where to go to, complete a workflow, as you put it. But ChatGPT does. So because it either has the documentation or it has crawled through through similar web pages before, but how did you get the LLM or ChatGPT in that case to actually crawl these webs for you? Was it hard to automate this into your software? Because I can imagine that it's not just as simple as writing a prompt into the browser window.
On paper, the concept will sound very simple. So first of all, you need a browser to interact with the website. You also have an LLM that we want to use for navigation. And then we need to develop this bridge in between. So given a page that the browser gives us when we visit a website, we then enumerate all the clickable elements on the website, on the web page, assign identifier numbers to all of these elements. We have a task. We have this concept of task that we ask LLM to perform on the web page. So, for example, let's say going back to the example of the flight booking, we have a task: book a flight. So we have this task, we have the page representation, and we ask the model, okay, which element should I now click on the website, on the web page? The model tells us, okay, you need to click button number 1 So for example, if it's probably a list of tickets, then click on this ticket. The page gets updated. So we like send this command to the browser. The page gets updated. We again receive the page representation of this second page, which probably will need like to fill the information on the page. And we again ask the model, and like the cycle continues until the model tells us, okay, stop. Like it seems like we have finished. We have the stop command. And that's the main loop for each task. However, the devil is in the details. Many pages have very different ways how they implement user interaction. Some buttons can be, for example, they might not have the text on them. They might just have some pictograms, like plus button. There are also these like hamburger buttons, like just three horizontal lines. So there is no text per se for each of those buttons. Some websites provide the labels if they support the accessibility options. So for the people who cannot see, they can provide the textual information for these buttons. Not all websites do that. So all this very like little details actually make it a bit harder to implement this bridge in between the browser and the model.
Okay.
Another thing that we did is automating this procedure, because for the insecurity testing, so what I just told you was very similar to other software developed also by OpenAI and other companies, which is assistant tools. The idea is similar, that to have a assistant on your computer that can do the task for you. I want to book a flight to Florida, I don't know. And it will go on the websites to fill your information, ask for your prompt, and maybe it will say, oh, I don't know, like this looks like sensitive data. Can you please do it for me, confirm it for me? So this is not really useful for security testing. So for us, it is important that there is no user being involved, because we want to do this as a part of the pipeline for the testing of the software. For example, you're a company, you just developed a new version and you want to test it, and having a user to also come up with all these tasks might be.
It's just time consuming, and
it is
therefore expensive.
Yes. So, for us, it is important to automate this procedure. Therefore, we have this separate step at the beginning of the scan, in which we do very simple crawl, just a shallow crawl. Just click on all the buttons on the front page. Nothing more, nothing less. And then on each page, we just ask the model, hey, here's the page. Here's what you can click on. Tell me, please, what can I do? And it gives you a list of tasks that you can perform. We collect these tasks, and then we feed it into this previous pipeline that I told you about, which is execute the task one by one.
Okay.
And the output of this pipeline is basically, now you have done the reconnaissance of the application.
Then you have a very, very detailed map that a random crawler would not be able to reach.
Yes.
Okay.
With all these deep functionalities, because this is very important for us, that we are able to reach all these deep parts of the application to follow the workflows.
In theory, it sounds really, really good. In practice, did it work?
It did. So of course, there are it wasn't 100% accurate. We've seen very different cases, from failed cases in which there was not enough context for the model, so it started to hallucinate and come up with a task that do not make sense on the website. We also had cases in which it performed way too well. We have this moment in our experiments which we called suffering from success. Because it did so well that it actually prevented it from proceeding. So what happened was it generated a task, delete a user from the website. So it went on the user management page. It saw itself, because it was the single user on the website. It clicked on delete button. There was a prompt. Are you sure you want to delete the user? It says, yeah, of course, yes. Click on yes. So it was deleted successfully. But the problem was that so each new task was executing full workflow. So it was logging out and then trying to log in again. So what happened was it tried to log in, but the user was not available anymore.
So you had to do it as the last step. You can't do it at the first.
Yes.
Okay, that's very fun. Yeah, okay.
So yeah, it basically, so we are solving one challenge that we have not used semantic information before, but now we have a second challenge that comes after it. Like, okay, you now understand what happens.
Yeah.
How do you actually guide the model so that it doesn't
basically hinder its own pipeline?
Yes.
Okay, that's sounds funny.
Yeah.
Okay, but now you have like this very detailed map of the web application. What web applications could you see that working on? I mean, what web applications did you try to test it on? And do you think you could also scale it to like very large web applications in the future? Like, I don't know, Facebook, Meta, X, whatever.
In our experiments, we tested the tool on 20 very diverse web applications. We tried to eliminate the bias in selecting this web application. So we covered the CMS systems, so this like, e-commerce programs. So for example, like if you want to run a shop, you probably would want to use e-commerce application, then like build your online shop on top of this application. There are like a lot of websites that allow you to do that, but you also can just download software and tweak it to your liking to get this running. We also have developer specific software, so GitLab in our case. We also had wiki engines, so the thing that powers Wikipedia, MediaWiki. About the large applications, so here's the thing, like it actually goes back to your question before on how do you test all these applications. And if like you said, can I test Facebook? Well, if you are Facebook, if you're a developer at the Facebook, then of course you can spin up some staging environment, which they probably do have. On which they already run other security tools, testing tools. You can just plug it there and let it run and see what it comes up with. However, when it comes to like external researchers, again, if you don't have a permission to test, or maybe it's specific, like also in the bug bounty field, most companies will probably not allow you to use automated testing tools, and they explicitly say that in their program description, saying that please don't use automated testing tools or like rate limit them and so on. And for us, this was actually like part of the ethical discussion in the paper, that now that we have implemented this semantic interaction with the websites, now we have this very real risk that our tool may be misused for, say, fake account creation, which is a big problem. However, thankfully, we tested this additionally, and we've seen that existing bot prevention mechanisms like CAPTCHAs, multi-factor authentication, for example, if you register, you need to use your email address, you need to use mobile phone number. All these things actually prevent you from using our tool for these purposes.
But it also prevents your tool from reaching every functionality you want to reach.
But as I said, like if you're running it
because you're running it in your own environment.
Yes. So as long as it's your own environment, there is no limit for you, basically.
Okay, so it would. I mean, I don't know if you continue it further and it makes the rounds at all the security conferences. Maybe so. Basically, a developer at Meta could download your tool and use it to.
Yes.
Okay.
That's I think the ideal scenario for the tool. That's how it should be used.
Yeah. Okay. In my understanding, if it is hard for a traditional random web crawler to reach like the deeper functionalities, they won't, as you said, pressing like the correct button 20 times in a row is very unlikely. So they won't ever reach like the checkout for the flight booking process. On the other hand, scanning a website semantically, like I would, so let's just put it that way: scanning the website scanning the website like a human would, like pressing the buttons they should do if they want to perform a task. I won't ever reach like other parts of the website that a traditional web scanner will reach, right?
Yes, so, that is correct. Yeah, there could be some unobvious, let's say, workflows on the website that you started a workflow, but then you suddenly halted it because you clicked on the other button, or maybe it might not make sense for you to click on cancel, but maybe there is something interesting when you actually click on the cancel. So there's definitely still areas that our tool might not reach simply because it doesn't make sense to, or maybe there was no task generated for it. Because I said, like, it's not still like 100% accurate. It might not cover all the possible tasks on the website, which is still actually like for the future work, it could be done probably. But in that sense, maybe combining these tools, our tool and all other traditional scanners, makes sense.
Would probably give you that additional detail in the map of the web page if we want to stick to that picture.
Also, like the hybrid approach might actually work.
Right. Interesting. But in general, let's get back to the concept of automatic testing. Why is reliable automatic testing such an important topic? Not only for you, but for the industry as a whole? Because, I mean, as we've seen, there is quite a lot of research going into there. There's quite a lot of money that companies spend for it. Why do you think it's so important?
I think the main reason is that there are only so many security researchers that can actually look for the vulnerabilities for you. And if you're a company and you have this rapid development cycle, like you pushing new versions every week or so, you just cannot afford to do the security testing for every single release. Not saying about any like new, just like intermediate release that is just internal. So for all these intermediate steps where you cannot rely on the traditional security testing, I think the automated tools are go-to. And the problem is that the security researchers are still way better than the security tools in general. Of course, like very experienced security researcher probably uses tools. Because it maybe has its own set of scripts that it likes to use for testing to just speed things up.
Sure.
But they're very custom and it's just not scalable. That's the main problem. So if you want to scale this process up, you want to do the testing as often as possible, you have to use the tools. So which is why we are trying to improve the tools so that you can run them in the background. And they will pump out all the vulnerabilities that they found, and you can fix them before they reach the market, the released the released version. And
but is there? I don't know. I have actually no experience with that, because of course I don't. But is there a market? So could you just? I don't know. I'm a developer. I have developed my first app, and I want to make sure it's secure. I'm not a security researcher, but I want to buy a software to test it for me. Can I just go somewhere and buy that, or do I need to go to? I don't know. How does it work?
Yeah, I think that's one of the problems maybe of this current situation, like in the market for security tools. That yes, you can go and buy some tools, but as a developer, do you know what exactly do you need to test for? I think this is like one of the. This is also one other problem that we have, that not that many developers actually know much about security in general. They do not experience. They do not know the current trends in security. They do not know what could go wrong in the program. So of course there may be some tools included with the programming languages, frameworks that test for you automatically. Like they say in documentation that yes, like you cannot use it in this way because it will be insecure and so on. But if you don't know specifically what you're looking for, it will be pretty hard for you to know what to look for, basically. Companies, I think companies most likely look for compliance. They just want to have this green mark that we test for vulnerabilities. We care for the user's privacy and security, so we run this approved list of tools that are in the specs. And that this is like probably the scenario for the most companies out there. For the more experienced companies, like with a larger maybe headcount, they might have a security team inside the company. And the security team actually made research. Okay, what do we want to test on? They will come up with a list of tools that they want to buy. They will research the market, maybe the businesses that sell these tools actually approach them and say, hey, we have this very cool tool, or maybe on the conferences. I don't know, there are maybe many different channels. But this is just a commercial market, because we also have the open source tools that you can use just as is, like they're free. Just go download them, install them. But it's all of this is a lot of work. Like you have to configure them, install them. You need to research what you're looking for. So there is no silver bullet, and like there is no go-to recipe for you how to test software.
So basically, outside of the, I don't know, if I'm a developer and I use a specific framework, that framework will probably have some security features built in.
Yeah.
But otherwise, there's like no tool that I can just buy and say, okay, please test my app if it's secure.
Yeah, there is no like antivirus for the like the one single tool that covers most of it.
Do you think there will be one day? I don't know. With the rise of AI,
I hope so. Either a tool that fixes all the problems, or maybe the problems are non-existent anymore.
Yeah.
So like the software already comes built in with whatever needed to prevent. But honestly, it could be also just a pipe dream. So
do you think we will go from error finding to error fixing automatically? Or is that like...
Error fixing is very tricky because automated error fixing means that, first of all, you need to confirm that you have fixed the error. And second, you need to confirm that you have not introduced a new error. So,
and your app is still working in the way it should.
And yes, and the app still works, because you can always say, hey, I have this very cool automatic fixer. Just delete the program. Problem
deletes
solved.
the user.
Yeah. Delete the user. Like, just don't use the application anymore.
It's a fix.
So this is like a whole area of research, automatic fixing, and there's a lot of work there. It will be nice if we have automatic fixing. Will we get there soon? I don't know.
Okay.
LLMs could help with that. There, like, people already try. Like most security research already play with the LLMs in one way or the other.
Yeah, but it sounds like you won't be out of a job for a while.
Definitely. Yeah.
All right, then. Thank you very much for giving me such a detailed look into your paper. That was very fun. I can't let you go yet, though, because as is tradition, I have to ask you some fun, quick questions at the end. So I hope you're ready.
Go ahead.
First one. What is the most surprising thing you have learned in your cybersecurity research so far?
How brittle the software is in general. Like all this software that you use every day, all these applications on your mobile phones, on all these websites. I don't know, even like your printers and routers. It's all these things have vulnerabilities in them. They are just waiting to be discovered by someone. That's it.
Okay, which is a little scary.
Yeah, it is very scary because it's everywhere. Like I think the most scariest are, of course, like you'll be scared that your phone that you use every day, that you take with you everywhere, can record you and of course, spy on you and so on. But also it's scary when you know that all the medical equipment has some software in it, and it's also not super thoroughly tested. Also the industrial machines, like all the SCADA systems that run the nuclear reactors and factories.
Because we don't really want to leave our listeners feeling scared. That is why CISPA is doing so much important research to actually secure all that stuff. We all working really hard to make all these things secure and make it so that to verify that, to make things even mathematically secure, that we can actually prove it.
Prove that there is this thing is secure. On a positive note, we've come a long way since we started to use software. It has been way worse before. Now it's much harder to to hack all these things.
Yeah.
And we are getting better and better every single day.
Yeah, that's good. That's a good note to end on. But we are not done yet. But So if you could instantly solve one cybersecurity problem, what would it be?
Probably passwords. I think it will be most impactful one, and this is like the most annoying problem that we have. That like also for the general public that no one likes passwords. Like you have to come up with them, then you have to store them somehow. It's very, very inconvenient, and inconvenience means it's most likely that it will be
that you will find shortcuts and ways around it.
Yes,
and,
yes. Okay. So if we can fix that, it will be super helpful to the worldwide population, I would say.
I can say for a fact that CISPA is also working on that one. So all right. What is more intimidating, a web bug that's hard to fix or a paper deadline?
I think the paper deadline will be the most intimidating one. Simply because it's more personal, kinda like you have to do the thing, and when you fix the bug, of course, you either trying to fix it as soon as possible, but still like the pressure, I would not say comparable.
But probably both are equally rewarding, though. So.
Of course, yes.
What is one cybersecurity trend that you think is overhyped?
Yeah, I wouldn't call any cybersecurity trend overhyped, simply because the more people know about the problem, the more likely it will get fixed sooner. So, for example, one of the recent trends was CPU architecture vulnerabilities. So everyone was quite intrigued by the fact that, well, the CPUs actually also could be hacked. And
it's not just software, it's also the hardware.
Yes. And now suddenly like we have an influx of works that trying to look into the vulnerabilities in the CPU architecture. And as a result of that, they are getting better every day. So as long as it like promotes this fixing things, I will be happy for any cybersecurity trend.
All right. Yeah, makes sense. And last question. If artificial intelligence could take over one part of your work as a researcher, what would you happily hand off to it?
I think as a researcher, I'll be very happy to have some kind of AI system that can catalog the papers, that can help me identify specific parts of the paper. So not writing papers for me, definitely, but like helping me to aggregate the data and understand the papers. Because for my previous paper, I've read way too many papers in a short amount of time, just extracting what they did. So it was not even like thorough reading. It was, I was looking for very specific thing that they did. And it was quite painful to look through all these papers, trying to find where do they mention this thing. And you also like double check yourself. Okay, did I forget it or not? To check this part. So you have to be very thorough. And so any AI system that could do that for me and say, hey, this section, you can look at this section, you can look at this section. Yeah, they mentioned this and this and this. If it doesn't find it, then I can go check it manually because maybe it had missed it. But if it did find it, then it's very helpful.
Well then, thank you, Alex, for coming here, for taking the time to explain all your great research.
Thank you for having me.
And all the best in continuing your work on automatic testing.
Thanks.
See you. Bye.
We have a nice future before us. This is just the first step for us. Yeah. There will be more.
Very nice. And I hope I'll have you get back as a guest then. See you around. Bye.
Bye-bye.